Hi there, and welcome to part 1 of my DIY programmable 8-loop pedalboard switcher build. This is probably going to be the most exciting and challenging build that I've ever undertaken. So I bet the very first question I get will go something like, why would you bother building this thing when Joyo make an 8-loop programmable switcher for about 170 bucks? Well, the Joyo version uses solid state switching. The version I want to build will have relays for switching, which will make it true bypass. Also, this one will be infinitely more programmable than what the Joyo version is. And I'll explain that a little bit later. On another note, while this project is going to be challenging, I hope it inspires others to have a go at their own projects, like yourself. Because when you build something yourself, you don't just gain another piece of equipment. You have the satisfaction of knowing that you built something yourself. You can customize the thing to suit your own particular tastes or requirements. You also gain and broaden your skill sets. So there's so much more to gain out of building something yourself. So let's have a look at what I've actually got for this project so far and what I've actually done as far as making this project work. The first thing I've got is a die-cast box which I can fit 8 switches on the top of and all of the connectors across the side. It's about 220 millimeters by 145 millimeters and it's sealable, and I actually have used this exact enclosure in my DIY tube distortion pedal build, and it's a pedal that I've been using ever since I built it, and this box has stood up no problems at all. There's the label on it. The other thing I'm going to use, and this will be the heart of the project, is an Arduino Mega, and as you can see I've already started working on things. I'll explain all of this a little bit later. So you will need to learn how to code a little bit. I will be posting the code that I've got on this thing so far down in the description, so if you want to copy it and make use out of it, you can. I have got one relay board. This is an 8-channel relay board that I can connect to the Arduino and control it. And I'll actually need a second one of these. I'll need 2 to make this happen. So the other thing I've got is input jacks. They're stereo 1/4-inch input jacks. I'm going to need a few more of these. I haven't quite got enough. I've got about enough for a little over half the project so far. So here we have the heart of this project. It's a Arduino Tech Mega, or an Arduino Mega. An Arduino is an open source prototyping platform that is microcontroller based. And it has pins that can be programmed as inputs or outputs in most cases. And you can use inputs to switch outputs and do all sorts of crazy things. Now, I'm no expert at this. I've only really been programming this on and off for a few months, but I'm getting the idea of it. And what I've actually got is I have connected pin 8 to pin 13 to these LEDs here, and while there's only 6, it's more for the problem solving that I'm going to have to do to actually get the project to work once I build it, because basically the project will do nothing unless we program it to actually do what we want it to do. So I had some little challenges I had to jump over, and basically these 6 LEDs would represent, say, 6 relays, but I can program it up later to have more. And these 3 switches represent 3-foot switches, more or less. So basically each foot switch is programmed up to turn a different sequence of the LEDs on, or fire a different sequence of relays, if you know what I mean, to turn certain loops on and off. as far as your effects pedals are concerned. So we'll press this one and you'll see that the outside LEDs in pairs are turning on. Then we'll press the next one and we get a different pattern again. We turn the next one on and we get a different pattern again. We go back to the first one, we get the first pattern. The second one, the second pattern. Back to the first, and you get the idea. Basically, you know, I've programmed it to fire them in a certain sequence, and it does exactly that. You hit that button, the sequence of LEDs or relays that I've programmed to work will actually work. Now, there are other hurdles that I'm thinking about attempting, and that's things like actually doing bank switching, so I can switch to a couple of different banks of programs, so I can actually go to another bank and the function of the switches will actually change according to which bank I'm on, as in like bank 1, 2, 3, 4. But I'll attempt that when I get to it. So the code for this, I'll leave that in the description down below so you can have a look at that. And here is the basic layout that I'm going to run with. I'll actually have another relay board here. So this is how everything will sit inside the box. We'll have 2 rows of these input jacks down here. We'll have the 2 relay boards feeding back to all of those jacks here. We'll have the brains of the thing here, the Mega, and I'll probably put a power jack either back here somewhere or over on this side somewhere and run it down to the Mega and to the relay board, because the relay board is going to require more power than what the Arduino can supply. I'll also make a hole in the box so that we can plug the USB in there, so I can connect the laptop to it and program it up to however I like. And the cool thing about this project is you can program it up in any way, shape or form so that those buttons do any function that you like, you know, anytime you like. You can change your mind. You don't have to even open the thing to program it a different way. So here is the foot switch layout, and I've actually just laid input jacks out in the configuration of roughly where each foot switch is going to go, and I'm guessing you get the rough idea. And the thing is, like, I can build this and then configure these foot switches as far as their function is concerned any way I like. So one idea I had was the foot switches, the 5 down here, could be like your actual loop switches, and these 2 up here could be bank switches, so I could go like down bank, up bank over here, and this one could be like the tuner button that cuts everything out and just switches to a tuner jack. And running with that, you know, I was thinking I could program that one up as my clean channel, then that one up as the clean lead channel, so it would actually get a boost in it as well. This one will be a dirty channel, and then the dirty boost, and then I could have this one to turn, say, a delay loop on and off, so I could add a delay in as well. I mean, literally the ideas are endless, and whatever you come up with you can just run with. I mean, you could have the thing configured in your pedal board and completely change it. You could literally have it that each switch represents each loop, so that, you know, it would just work one pedal. So you could turn that pedal on, turn the others on, turn others off, independently of one another. It's, the sky's the limit. So I'm hoping in the next 2 weeks or so I can do an update video, and hopefully we'll be a bit closer to having this thing built. So I hope you've enjoyed part 1 of this series. If you have, like the damn video. Don't hesitate to share the video, because if you've enjoyed it, somebody else is bound to enjoy it. Also, don't hesitate to subscribe, because I'm hoping to do an update on this one in about a fortnight. Hi there, and welcome to part 2 of the DIY Programmable 8-loop pedalboard switcher. So where am I up to with this project so far? Well, I haven't made a terrible lot of ground on the hardware side. I've made some ground on the software side as far as the programming is concerned. I've solved a couple of problems there. I can now switch between channels and actually create a series of banking situations where you have banks and then basically patches that will turn on different loops to suit yourself. I will show you where I'm up to with that. I will leave a copy of the sketch or the program down in the description, so you can copy and paste that to wherever you like. So where am I up to hardware wise? Well, I've kind of got the lid roughly marked out. I need to make sure that everything's going to fit. I don't know whether you can see those lines or not. Oh, that's a better angle. So you can see the line across the top here is the line for the LEDs, and I've actually marked the spacing out for those. Then we have the top row of switches, which there will be 3 switches. And I'm just not sure how far the last 2 will be, so I haven't marked those yet, but the center ones will go here and here. So we've got 3, 2, and then 3 at the bottom. So I've just got to make sure everything's going to fit internally before I go, you know, drilling holes and making a mess out of that. Also, I have 2 relay boards now, and I've found that they are going to be an extremely tight fit. I've had to check some out of one of the boards to actually get it to fit inside the enclosure, because the enclosure has these like sort of raised internal sections or ribbed sections that are there basically to screw the thing down, like it goes all the way through. So I thought maybe I could like die grind these out or Dremel these out, or I could just take a little bit out of the board and actually get it to fit like that. But it's going to be extremely tight, because I've basically got to get the 2 boards in there and then have my jacks across the top, and they'll be 2 deep, so there'll be a jack on the top and the bottom, and there'll be 16 of those right across there. So that is a little problem I need to solve in itself, but I'm very close. The tolerances are fine as, but I think I can get it to fit. Also, I've got more of these guys, so I can finish that part of it off. And something, I don't know whether I mentioned it in the last video, but I intend to actually put these together in that sort of fashion and actually solder each one of these legs together so that these are coupled together, because they actually switch. They're closed circuit to the pins, so basically when I have nothing plugged in here, this will act as if it was just a piece of cable in here, and you know, instead of being totally open circuit, so that if you don't have anything plugged in here and you actually hit the button that turns this particular pair on, it will basically just return it. You won't end up with that 50 or 60 cycle hum that you'll get if it was open circuit. So that's a little thing, and I've done that similar things to that before with other pieces of equipment, and I thought it'd be a nice thing to put into this one. So at this stage I've still got to get the foot switches. I've got shitloads of LEDs here, so that's not a problem. But yeah, I've still got to get the 8 momentary foot switches. I still have to get a little bit more mounting hardware to mount the PCBs. I've got the mounting hardware for the Arduino Mega board. Like, I'm just going to use these little guys that I pulled out of something else, but I've still got to get some for the relay boards. So where am I up to with the programming side of it? Well, basically I've got it sorted, so now I can switch between two banks, which is indicated by these two LEDs here. So you've got like bank 1 and bank 2, and these 6 represent the relays that you'll be switching, or like each loop that your effects pedal will be on. All I've got to do is connect them to relays. These bank LEDs don't need to be connected to anything else, just an LED, so you can visually see it. And I've already got this thing powered. Later on I will actually add in the void loop, which is like the one-time run program when you first power the thing up, to actually automatically turn one of these on. I haven't done that at this stage. So when I press the bank button, or the button that I've nominated as the bank button, it will actually just turn the first one on, and then we can proceed from there. This button here is our bank button. These 3 are our different programmable loop buttons, or our patch buttons, if you want to call them that. So I'll press the bank button, and you'll notice we get an LED on here. I'll press the bank button again, and I don't know whether you can see it, but I've got to sort that out. For some reason that guy's really dull. Don't know why. It seems to be the same resistor value as the others, so anyway, I'll sort that out later on. So we'll go back to the brighter one, and if I am to press, say, the first button, you get a certain sequence of those 6 LEDs, and I'll actually be able to easily make this like an 8-loop program. It's very easy. I've only got to add another 2 lines basically per patch to make this happen. If I press the second button, we get another sequence. If we press the third button, we get all of them on, which is just another sequence. I can program them to do whatever I like. Now, if we press the bank button, we go over to the other one, and you can just see that that's on, I hope. And it hasn't changed yet because I haven't pressed the patch button. Press the patch button, we get yet another sequence. We press the middle patch button, we get yet another sequence. And we press the third patch button, and we get another sequence again. We'll go back to the first one. I'll press the third patch button, and you'll see that they'll all be on. Go back to the other bank. I'll press that first patch button again, and it goes backwards and forwards. So basically, you know, this is pretty much all you really need. I can easily add additional bank LEDs and bank programming to this. You know, the sky's the limit. I mean, you could have 4, 5, 6, I don't know, whatever you like as far as your banks are concerned. You could have more than 8 LEDs. You know, there's still plenty of spare pins on this Mega, so I could just literally keep going if I wanted to. It really comes down to the limits of your box, the limits of, you know, how many different patches you actually want to run, like how many different configurations between the 8 LEDs or the 8 loops that I'll end up with. So I'll leave a copy of that sketch or that program down in the description so you can copy and paste. But you know, this is a real goal that I wanted to achieve, to be able to do this bank switching, and I've pretty much got it worked out. So you know, the programming's essentially done. I've only got to tweak it a little bit, tidy it up, the problems have been solved as far as I'm concerned. Now I've just got to get to and do the hardware side of it, get the thing built, and then run that program in. And hopefully down the track, I may actually create several different programs that I can run. I'll sit there and write up new sketches for it, so I can do multitudes of different things, maybe run, like, instead of just one patch button, maybe two, so you can go up and down, or you know, just different configurations. Maybe, you know, somebody might need some help, they might like me to write a sketch for them. I can probably do that. Anyway, I hope you found this video interesting and informative. Let me know in the comments section any ideas that you have. Have a look at the sketch, and if you're kind of down with this C coding business, or C+ coding, or, you know, Arduino coding, and you see something that I could fix up, let me know in the comments section. It'd be good. Have a great day. Give the video a thumbs up if you liked it. Don't hesitate to share it, because if you liked it, somebody else might. And subscribe if you want to see more. This is a multi-part series. We're only at part 2. I think there'll probably be 4 or 5 parts to this video, to this series, before I'm finished. Have a great day. I'll catch you later. Hi there, what's up? Welcome to part 3 of my 8-loop programmable DIY pedalboard switcher. I've had a busy week this week. I haven't been able to do much on it, but last week I did get a little bit done. I haven't advanced the programming anymore. It's pretty much where it needs to be. I've just got to make a few alterations to make it do what I want to do, but pretty much all the problems were solved, and I showed you that in the last video. So let's check it out and just see where we're up to with the device itself. So here's the front panel, and I've got the 8 switches installed, the 8 momentary foot switches. We've got 8 LEDs to tell us which banks are turned on when we made a selection. I've got 3 LEDs here to switch between 3 different banks, so that each button can do something different, you know, on each bank. Also, I figured that if I want more options, I can switch to using binary to indicate which bank I'm on, so I can get more banks than 3. Also, I've kept these pretty tight, so I can, if I wish to, install a 7-segment display there, and then I get up to 9 different options, and it's easy to read, but that'll require a little additional programming. If we go over to the back panel, or the back of the panel I should say, you can see the back of the switches. I will make one leg on each of these switches common, and common them all up, and they'll go to ground, and then all of the hot or active sides of the switches, or the other terminals, will go to each pin on the Arduino board to actuate the programming, more or less. The 3 LEDs here, I've got the printed circuit board, or strip board, or ferro board, or whatever you want to call it, in here, and I can run the resistors for those across. I've also ran them so one wire is common, or one strip is common for the negatives, and I'll do much the same for these across here down the track when I get to that. Okay, so let's check out the main box, the enclosure itself. At the moment I'm just trialing or testing a few things. I have the relays mounted. I've got all the holes drilled at the front, hole drilled at the side for the output, hole drilled there for the input. I've got a hole marked, I don't know where they went, there for the USB input, so I can program it. And I've still got to put a spot in for a power jack. So here I'm just getting an idea of where or how everything's going to fit together, and I'll probably have to take these boards back out to mount the rest of the input and output jacks for each loop. So here's what I've done with the input and output jacks. I've actually soldered them together, and then one wire will be input, one will be output. And in this configuration, when there's nothing plugged into these, it actually is a through. So if you have nothing plugged in and it happens to be programmed in, it will still work. It'll send the signal straight through as if there was a cable plugged in here. And that's the idea of that. These line up, so they'll go through like so. So that shouldn't be too bad. I've got the holes drilled for the Arduino board, and I've countersunk all the screws in there. I think I'll show you a little bit more of that later. But I've made some progress on it, and I'm hoping to do a lot more over the next 2 weeks, and I will give you another update and let you know where I'm up to. I'm really excited to get this finished and actually get to the stage where I can program it, because then I can test everything out, and you know, the sky is the limit, like as far as what I'll be able to do. Like one button press will completely change the configuration of what pedals I have connected. And on the fly, like when you're coming up to a solo or something, when you're playing in a band situation at a live gig, that's really handy, so you don't have to dance around turning delays on and off, turning boosts on and off, going from say clean to dirty as well, like, or a combination of any of those things. You can all do it with one button press. So in my next video, due to popular demand, I've had numerous requests for this over the years, and this was actually one of my very first videos on this channel. I'm going to do up a schematic of this guy here, which some may recognize. And you know, I've had numerous requests for it, so I figured I may as well draw it up so that somebody else can get a little bit of inspiration from it, and it can be shared around. There's nothing really significant about this circuit. It's not anything magical. It's pretty much a JCM 800 front end, just adopted to have one hot input and basically configured so that you can run it into, you know, whatever you like, into a pedal or into an amplifier. But I'll be drawing this up, explaining it, putting some voltages up there, and actually taking measurements off this as I go, so that you can get as near to it as possible if that's what you want to do. I'll explain the power supply setup, the high voltage, which is here, and the low voltage, which is here. And yeah, I'll just put it out there so somebody else can get some benefit from it. So I hope you enjoyed this video. If you did, give it a thumbs up if you like. You know what to do. Have a great day. I'll catch you later. So here I am in my workshop, just piloting the holes for the jacks to go in. So with the smaller drill bit, the torque when the drill actually grabs isn't as much, and what I can do is just hold it by hand. But with a bigger drill, don't like holding it by hand as much. Here I've ground off some of the internal protrusions that were getting in the way. So I've kind of worked out based on where these switches are going to go and everything else internally, where I can actually put the input and output jack. I haven't got the switches yet. I'm still waiting on them to turn up. which is a major hold up for this project once I get to that point. But what I've worked out, if I put it near the center, just offset towards the front slightly, or possibly even the back slightly, might go the back side actually, I can, if I keep it up fairly high, I can miss everything, and that'll work fine. So I'll mark that and proceed to make that happen.
Now I've got 2 lines there. I'll just go down the appropriate distance. I'll put that back over there. Which I think, might be optimally. $20 is probably too much, probably. We'll try 15. Yeah, that should be plenty. Gives me clearance top and bottom, so that should be fine. 15mm it is.
Basically, I've marked them both. Now you just center punch it so that your drill bit centers itself exactly where it needs to be. I'm just using a claw hammer because that's all I've got at the moment. Okay, so I went through and I piloted those and drilled them. Hi there, and welcome to part 4 of the DIY programmable pedalboard loop switcher build. I've made some progress on this, but I have been really busy lately, working, had family stuff going on, gigging. There's an example of that. And I just haven't had the time to actually finish this project, but I have made some headway on it. So let's check it out. So here's the front panel, and externally it hasn't really changed much at all, but if we turn over, you'll see that I've made quite a bit of progress here. We've got all the boards wired up with the LEDs on them. We've got connectors to go to the Arduino board to actually run those LEDs. All of the resistors for the LEDs are on the board so that they get the correct power supplied to them as far as current and voltage is concerned. And all of the switches are wired up, and I've made up this this board to actually connect up to the Arduino Mega. So that all of the switches will work. They've got resistors as well to ground, so that the switches will actually pull the pins high whenever they're pressed, and that's how the Arduino will know that you've actually pressed a switch and want to make a programming selection. So if we go to the main enclosure, and you can see I've made some progress here as well. I still haven't mounted the Mega. I've had problems with that. There's very tight tolerances on some of these holes, and there's tracks running quite close to these holes, and yeah, I've just had a few dramas with mounting this thing. I would have thought that it would have been a lot easier to mount than it has been, but anyway, I will get on top of that. Apart from that, the entire signal path has been wired up. So there's the input jack, and that goes all the way through all of the relays to the output jack, and there's a through signal path when there's no power on this thing, which is a handy little thing to have. So if you have a power failure within the board itself or something goes wrong with it, you can always unplug it and you'll still have a signal going to your amp. Apart from that, I've got these ribbon cables connected to the board. I've also soldered wires directly on the back of the Arduino board to the power jack, just to save a little bit of room so I don't have to use this jack here. But yeah, it's getting very close. I'm very close to having this thing running. I've just got to mount this board, connect up the front panel to it, which won't take very long at all, and run power for each of the relays, just a positive wire going over to the power jack, and that's pretty much it. And then we're up to the programming stage. So probably next video I'll be up to the programming stage, and yeah, it should be good. So I hope you found this little update interesting, informative, and maybe a little bit inspirational. If you have any comments or questions, please leave them in the comments section below. Hi there, and welcome to part 5 of the 8-loop programmable pedal board switcher. Well, that about covers the guitar noodling for this video and probably the next few. As you can see, the loop switcher is now fully functional. It's mounted to my pedal board. I've actually been using it for about 2.5 months now and finding out any problems that I've had. Hardware wise, it's pretty much completed. I will do some tidy up work with the wiring and such sometime down the track. Programming wise, it's at a point where the bulk of the programming is done. All I really want to be able to do is add a few more banks of options, just basically to add a few more combinations of effects and things down the track as I need them. But at this stage, it's kind of where I want it to be. I can use it in the band that I play in, and you know, I don't have any issues with it. So here's the front panel, and as you can see, I've vandalised it with a permanent marker. That's because I've done some pretty big programming changes a couple of weeks ago, and I had a gig the next day, and I just marked it out roughly so that I knew where I was at a glance, so that when I made transitions between sounds it was fairly seamless and trouble-free. And that's the cool thing about this. If I don't like where that bank button is, or I want 2 bank buttons, I can always program any buttons I like to do whatever task that I want them to do within this piece of equipment, because every button just goes to an input on the Arduino board, and then every set of relays and LED is connected to an output on the Arduino board. So it's very versatile in that way, and many of you would know that already because you've seen what I was planning previously, or you've probably got some Arduino experience. So what actually happens when I start this up, on power up, there is a mute relay in this location underneath the cover, which shorts out the output and prevents any sound from coming out of it. During that time, every pair of relays on each loop gets fired. That pretty much shorts out any static charge that accumulates across the contacts and will cause initial popping sounds as you select different patches basically on the device. After that, it does like an indicator or lamp test, and each LED fires off so you can see that they all work, and then it sits there in patch 1 waiting for you to hit something. Even though nothing is turned on and none of the loops are actually on, when it's sitting there waiting, your guitar is still making it through to the output, just with no effects. In my particular case, you might program a patch up that has no effects on it. You know, everything is an option. So let's power it up and you'll see that. You would have seen that at the beginning of that last clip. That was the relays, now the LEDs, and it's sitting there waiting patiently. Now I can press the clean button, which is what I normally do, and I could program that up in the void setup and actually have it go straight to that patch right at the get-go. But I prefer just to let it do its thing, and I'll leave it with no patch enabled. Sometime down the track I may want to do alternative things. I may even program it up the way I just suggested. So obviously, depending on the layout that you choose, the type of enclosure that you choose, and whatever takes your liking as far as that layout's concerned and the function of each button, you could come up with any combination or configuration that suits you. Anyway, let's open it up and I'll show you what it looks like inside. Okay, let's have a look inside. So those who've seen the previous video will find this kind of familiar. The two 8-way relay boards, of course, and in the previous video I hadn't yet mounted the microcontroller, the Arduino Mega, which is now fixed in place. Also, you wouldn't find this relay familiar at all. This is the mute relay, and preferably it would be better if it's closer to the output jack. In hindsight, a different shaped enclosure would have been more of an advantage to me. Something long and slender would have been a little bit more ideal. It would have spaced things out, got the microcontroller further away from my signal path and things like that. They're just things that you might be able to incorporate into your build if you decide to do one. So every pair of relays, so you've got two here, two here, two here, two here, and so on and so forth, is actually coupled up together on a single output via this connection here to an output on the board just over here. I've done that so that they fire both together. I was thinking about firing them individually and maybe having one shut or open or whatever, have them close and open at staggered times, but once I got the mute relay happening, it just made more sense to have them fire together and make that actual procedure as short as possible so that I could keep the mute time way down to something pretty low and reasonable. And as it stands, I think it's around 18 milliseconds in the programming, which by the time the relay actually fires close and then back open, it's probably a lot less than that. I think below around 10 milliseconds the relay doesn't actually fire off properly. It doesn't actually close, so it may take 5 milliseconds for it to actually change state, which means that the actual off time or mute time is something like 8 milliseconds, possibly. Don't quote me on that, I'm just guessing. It's just like an educated guess. So yeah, relay boards, output jack, input jack, power jack. Incidentally, with the power, I changed the polarity to the same polarity as all Boss pedals and Ibanez pedals and so forth. The Arduino input jack is actually the reverse, so don't get caught out with that. If you are going to power it from your pedal board, and most pedal board power supplies are set up to handle Boss, Ibanez, Maxon and so forth power, they're set up in the opposite polarity. So I believe with the Boss stuff, the shield is positive and the inner conductor is negative. So let's power it up with the lid off, and you can see the relay is firing off in here. So it's done that whole thing. The mute relay is just let go, so it was closed for the entire process. So now it's sitting there waiting to go. No relays are firing anywhere. It's open circuit. So I'll hit the clean, and as you can see, these two here fire. If you're lucky, you might see a little flash over here. I'll just switch and you can just see a momentary flash around this area, which is coming from our mute relay. I'll fire off another one and you should see that little flash, hopefully. So the relays are actually quite noisy when they fire. You can hear that clicking sound. but none of that actually makes it through to your amplifier. It's pretty much deadly silent because of this little guy actually being closed circuit and shorting out the output as the relays change state. There is one other little option that I've programmed in on this, and if I actually hold in these two buttons here, it goes into a tuner mode where it fires the mute relay and actually sends the signal path out through to the tuner. So we'll hold those in and we're in tuner mode, and if I open it up, you will see that this little relay here is fired, and we've got a pair of relays here firing to actually send the signal path out to the tuner. So you can tune your guitar muted, and when you want to go back to playing, all you have to do is hit any button on the board. You can hit any button and away you go. You're back to being live. So with the bank programming the way it is, I can pretty much just hit the bank button and it'll scroll through. If you notice here, I've got 3 banks operating. Later on I'll do combinations of the LEDs. But as you can see, it just scrolls through each bank. And as you play, say you're on a patch and you want to go to a patch that's on a different bank, you can actually scroll through while you're playing, and then when you get to the bank that's got the patch that you want and you're ready to go, you just hit that button and bingo, you've got that patch. So then you can go back to where you was before, hit the button, and you're back to whatever patch that you wanted to select. So you can actually do that while you're playing and it won't affect the sound at all, which I believe is with the commercial versions that have all of the gate type switching, they do a similar thing, and it wasn't that hard to program up actually. Another thing worth noting is the hole in the enclosure for the USB jack on the Arduino board. Just makes it handy. You don't have to open up the device to actually program it up. You can just plug straight in and program away. Well, I hope you found this video interesting and informative. If you have any questions or comments, please leave them in the comments section below. If you want to like the video, give it a thumbs up. If you want to subscribe, just do that. Don't forget about that notification bell thing. In the next video, we'll discuss the programming. I'll go over every aspect of it in as much detail as I can. And have a great day.